video, we are going to learn artificial neural network using backpropagation. This is one of the most popular classification algorithm used. The architecture. The architecture of a neural network is usually composed or defined based on the following: number of layers, number of neurons or units in each layer, type of connection between the layers. One of the most important element in artificial neural network is the parameters or called weights. The weights for the neural network is learned using an approach called backpropagation, which essentially uses gradient descent approach. To find the best parameter this uses minimization of the error in the output. The innovation in both processor computing power and the use of graphical processing unit, backpropagation algorithm is largely applied and is very central to deep learning. This figure shows a sample architecture of the artificial neural network. In this architecture, you can see that the circle represents the neurons or the unit, and the line which connects these neurons or units are called the connections. Here you can see that the first layer is called the input layer. Next to the input layer is the hidden layer 1, and the third layer in this architecture or figure is called hidden layer 2, and the last layer in this architecture is called output layer. Another example architecture is shown here. In this figure, you can see that it contains only one hidden layer. So, according to artificial neural network, you can have infinite or large number of 0 to large number of hidden layers. So you can see that the input layer, the number of neurons in the input layer depends upon the size of the input or the dimension of the input. Here you can see that the dimension of the input is n, and the links connecting the input layer or the connecting between the neurons are generally represented here as W1J. That is, for this one it is W11, W12, W13, and for the second neuron with respect to the neurons in the hidden layers, it is represented as W2J. That is W21, W22, W23. So it is generally represented as Wij, where I represents the neuron in the input layer and J corresponds to the neurons in the hidden layers. An artificial neural network architecture comprises of a minimum of 2 layers and can even have hundreds of layers in more complicated networks. Every architecture will have an input and output layer, which comprises the minimum number of layers. The layers other than the input and the output layers are called hidden layers. An architecture can have 0 or more hidden layers. If an architecture contains no hidden layer, then it is called a perceptron. If there is only one hidden layer, then it is called multi-layer perceptron. If an architecture contains 2 or more hidden layers, then it is called deep neural network. This figure shows the computation related to the artificial neural network. This is a sample multi-layer perceptron, that is an architecture with one hidden layer. Here the layer shown below the bottom is called the input layer. Here the input to the input layer is the the values corresponding to the input x. That is, x1 is the first in a feature value of first feature in the input x, and x2 is the second one, and x3 is the third one. That is, the dimension of the input x is 3. So corresponding to the dimension, the input layer here we have 3. So this input layers, neurons in this input layers are connected to the neurons in the hidden layer. Here this is every neuron in the input layer is connected to every neuron in the hidden layer, and this is called fully connected. In association with the input layer, there is a neuron called bias. That is, a bias quantity is connected to the hidden layer. Also, you can see that the same bias neuron is associated with the output layer. You can see some representation in the hidden layer as well as in the output layer. This comprises the operations associated with each layer. You can see that the first operation associated with the each neuron in the hidden layer is called the calculation of net input, that is represented here. And after calculation of the net input, you have to apply the activation function. In artificial neural network, there are multiple activation functions applied. Some examples to this activation functions are softmax, sigmoid, ReLU, etc. Input layer. The number of neurons in the input layer is typically the number of attributes or features of the data under consideration. In typical feed-forward networks, the input layer is fully connected to its immediate next hidden layer. In certain architecture, it is not mandatory that the input layer be densely connected to hidden layers. Hidden layer. The number of hidden layers in a multi-layer architecture determines the depth of the network. The hidden layer holds the transformation applied to the input at various levels. The first hidden layer contains the transformation applied to input layer. This transformation is achieved by obtaining a weighted sum of the input and then by applying an activation function. The activation function applied to a deep neural network is typically non-linear. The non-linear transformation helps to learn more complex patterns as compared to linear transformation. Also, more number of hidden layers helps with learning complex patterns of the data. The output layer. The final prediction is obtained at the output layer. This prediction is a continuous real value in case of regression and is a discrete label in case of classification. Usually, for classification problem, the output layer will contain probabilities for each of the classes. Common activation functions are sigmoid or softmax activation depending upon whether it is a binary classification or a multi-class classification. Now coming to the algorithm of artificial neural network using backpropagation. D is a data set consisting of training tuples and their associated target values. L is the learning rate. And you have to give a sample network. Usually it can be a multi-layer feed-forward network. The output is a trained neural network. In artificial neural network using backpropagation, there are basically three steps. The first step is called propagation of the input, and the second step is called backpropagating the error, and the last step is called, or the third step is called the updation of weight. In the first step, propagation of the input, in the input layer you can see that the calculation is the output of the input layer is nothing but the input itself. So when you feed xi to the input layer, the output oj corresponding to xj, it is ij itself. For each hidden layer, the uh, the output of the hidden layer is, that is, it is the net input, that is, it is nothing but summation of wij oi plus theta j. Theta j is nothing but the bias quantity and wij is the weight vector or the parameters in the artificial neural network. So in the first hidden layer, the oi is nothing but the input itself. Coming to the output value of a particular neuron with respect to the hidden layers or the output layer, it is oj is equal to 1 by 1 plus e raised to ij. Ij is the value which we have calculated in this. The next step in the backpropagation algorithm is backpropagating the error. So you can have two different equations for backpropagation or calculation of the errors. Here this is for each unit in the output layer. So error calculation with respect to output layer and the hidden layers are different. For output layer, error j with respect to unit j, it is equal to oj into 1 minus oj into tj minus oj. oj is the value which we have evaluated using this equation, and tj is nothing but the target value which we have in the training set. For each unit j in the hidden layer, the error is calculated as oj into 1 minus oj which is calculated using this equation into summation of k into error k wjk. The, it is used to compute the error with respect to the next higher layer k. So this k represents the higher value or error calculation with respect to the higher neurons with respect to the current layer. Now the next step in the backpropagation algorithm is the updation of weight. Here the updation of weight is delta wij is equal to L is nothing but the learning rate into error j plus oi, that is the error calculated with respect to the this equation, and final weight is equal to the previous weight plus the updated weight, that is wij is equal to wij plus delta wij, or called weight update. And once we have updated the weight, there is another quantity called the bias quantity. Again, change in bias is equal to L into error j. Error j is a similar factor value which we have calculated before. And the change or bias update, all theta j is equal to theta j plus delta theta j. Terminating condition for training. All delta wij in the previous epoch are so small as to be below some specified threshold. You can use either of this terminating condition to stop the algorithm. The second condition is that the percentage of tuples misclassified in the previous epoch is below some threshold. So you have to predefine a accuracy rate. So if it is below that accuracy rate, then you can stop. Pre-specified number of epochs has expired. That is a third condition. In practice, several hundred of thousands of epochs may be required before the weight will converge. Thank you.